Hello everyone. In this lecture video, we are going to see some concept about parsing of theory of computation. So initially, what is parsing? Parsing is analyzing, it's a process of analyzing a continuous stream of input what you have given to your machine. The set of input will be analyzed continuously for checking its grammatical thing. So whether the given string accepts the formal grammar or not, for that kind of thing we are using parser in our system. So initially the process of parsing can be classified into two types, top down and bottom up. So in the top down parser can be further classified into recursive descent and predictive parsing. So recursive descent, in this the grammar production will be checked using the parse tree. You have to generate the parse tree whether the given string is accepted for that particular grammar or not. Then in this predictive parsing, the grammar it can be further classified into recursive predictive and non-recursive predictive. In this lecture video, we are going to see about non-recursive predictive parsing. So we are going to discuss about non-recursive predictive parsing. This is the grammar that I have considered for solving this non-recursive predictive parsing. So this is the set of prediction. Before doing any parsing in that predictive parsing, either it can be a recursive or non-recursive, we need to eliminate the left recursion. So what is a left recursion means? If this is in a grammar, this is called a non-terminal. That means that the element which produces something, which has some production, that is called a non-terminal, and the symbols which the element which doesn't have any production further is called a terminals. So here, if the non-terminal element generates its that means recursively, if it generates the same element, then it can be set as a left recursive grammar. So here look at this, the grammar E, this production E generates E plus T. So here recursively it generates itself. So this is called a left recursive production. So here the parser cannot compile a recursive production easily. So we need to eliminate that left recursion before doing any parsing process. So for that we are having some set of rule. So we need to eliminate left recursion. So here in this grammar, this production here, it can be written as E gives E plus T and E gives T. So here this production is said to be a left recursive production. It producing its same element again. So this is not left recursive. So for eliminating, we need to give T E star E dash. So why we are using E dash means here we are generating another new element in order to avoid the left recursion. So for this E dash, sorry. So we need to write as plus T E dash or epsilon. Okay. So that means in order to simplify this, we are using E dash. Okay. Then here in this T star F and T tends to F. Here this production is said to be a left recursive production. In order to eliminate that left recursion, we are making it as using this element F t dash. So for this new element, we will be using this element star f t dash or epsilon. Okay. Then here look at this. This production of f doesn't give left recursive production, so we can write as itself. So f tends to e r id. So whatever the parsing thing you are going to perform, initially we need to eliminate the left recursion. So if the grammar is said to be recursive, then it will be the ambiguous grammar. So ambiguous grammar does not give the proper parsing thing. So we need to eliminate the left recursion in order to make it, we have to make it as an unambiguous grammar for smooth parsing. Okay. Then after eliminating the left recursion, now this is the set of grammar we are going to do parsing. Okay. So here initially we need to find, first thing we need to do is eliminating left recursion. The next one we need to find first of all non-terminals first. Okay. So here what are all the non-terminals we are having? E, E dash, T, T dash and F. For these productions we need to find the first. So first of E, let me write first of E dash, first of T, first of T dash, first of F. So for all this productions we need to find the first. So what is the first means? So if you are going to check the first, so we need to check the production. So here E tends to T E dash. So what is the first element of the E's production, that is E tends to T. Okay. Here T is also a non-terminal. It also have some further production. So then we have to move to this T. So here look at this, E tends to T. T is also a non-terminal. If it is a terminal, you can directly write that as a first element. But here it is a non-terminal, so we have to see its production. So T tends to F T dash. Here the first element is F. F is also a non-terminal, so we have to move further. So here look at this, F tends to open bracket. Here open bracket, as I said, the element which doesn't have any further production in the grammar, that is said to be a terminal. So here open bracket and ID. So here it has, F has two productions, that is F tends to open bracket E close bracket or F tends to ID. So here the first of E is open bracket and ID. So then now we have to find first of E dash. So look at this, E dash tends to plus. So here the plus is a terminal symbol, so we can write it directly plus. Then it has also another production, that is E dash tends to epsilon. So epsilon. Then what is the first of T? Here T generates the first element of T's production is F. F is a non-terminal, so we have to look at that. So F tends to open bracket and ID. So what is the first of T dash? Here it is star and epsilon. It is a terminal, so we can write it directly. So what is the first of F? Open bracket and ID, those are also terminals. So whenever you are getting the grammar for solving non-recursive predictive parsing, we have to check whether the grammar is left recursive or not. If it is not left recursive, then you can directly find the first and then we need to find the follow. After that, we need to draw the parsing table. Then we can check with the stack implementation of whatever the input given. But if the grammar, if any one of the element is also a recursive element, we need to eliminate the left recursion using the formula. Then we need to find the first for all the non-terminal productions. Okay. So the next step is we need to find the follow for all the non-terminals. So for finding the follow, so For finding the first, we had some rules that if the first element of the production, any grammar production is a non-terminal, then we have to shift to it. Then until we are finding any terminal element, we have to move toward it. Then for finding follow, we are having some 3 set of rules. That first one is the follow of start symbol. So here the start symbol of this grammar is E. The grammar starts with E. Okay. The follow of start symbol contains $. So whatever the thing is the start symbol of your given grammar, it always contains $ in its follow. Okay. Then next one, if we are having any production, A tends to alpha, B, beta. So now if you are, for example, if you are going to find the follow for this B element, that means the element which is present in between any 2 elements, then the follow of, this is the sample production, then follow of B is equal to first of beta. That means here look at this, the B is followed by beta. So here if the follow what you are going to find, if it is present in between 2 elements, then the follow of this B is the first of this beta. Okay, because this beta is following your B. Okay, so first of beta except epsilon. So if the first of beta contains epsilon, you should not consider that in your follow. Okay. Then if another rule, alpha, beta, sorry, B. Okay. Here what I have said, if we are for the element for which you are going to find the follow, it is if it is present in between, you have to look at the left hand side. So if it is present in between 2 elements, the follow of the what element you are going to find is the first of the following element. Okay, except epsilon. Okay, so if you apply that epsilon to this beta, then it will give this, the production will be like this, right? Because the beta will be the null one, epsilon is a null one. Okay, then in this case the follow of B is the follow of A. Okay. Okay, these are all the set of rules we need to remember while we are going to find the follow. Okay, that means first one, the start symbol, the follow of start symbol always contains $. Okay, then if the production for finding look one thing, for finding the first, we have to see the right hand side of your production. That means for finding the first of E, so what will be the first production? We have to look at the right hand side, but for finding the follow, we have to look at the left hand side. Okay, where the element has present, what is the element following that element, what we have to find follow for. Okay, so the start symbol always contains $. The second one is if the production is like this is the sample production, that means A tends to alpha, B beta. For example, if you are going to find the follow for this B, okay, that means in the left hand side it is presented in between 2 elements, then the follow of this B is the first of beta. Okay, what are all the elements present in the first of beta will be the follow of this B. Why? Because this beta is following your B. Okay, and in that case you have to eliminate epsilon. You should not include epsilon into the follow. Okay, so then the next rule is if your production is like this, that means if you are going to find the follow of B, it doesn't have any follow, or else the condition may be if it contains epsilon. So if you are applying this epsilon to your beta, then it will become like this, right? So in that case, we have to write the follow of B should be the follow of A. It is in a cyclic manner. Okay. So what is the non-terminal which produces that that follow will be the follow of B. Okay, these are all the rules to remember while we are finding follow. So now we are going to find a follow for this set of eliminated left recursion eliminated grammar. Okay. Follow. So here in this grammar, E is the start symbol. So as per the first rule, the start symbol always contains dollar in its follow. Okay, so dollar. Then we have to check where the E is present in the left hand side. So in this production, E is present here. Look at this. This follows the second rule, that is A tends to alpha, B, beta. Okay. So here this is our thing to this for this element we need to find the follow. So here as per the second rule, follow of B is the first of beta. Okay. Here since the beta is a terminal, we can write it directly. So then we have to find the follow of E dash. So in this production, E dash is here. Okay. So it looks like a third rule, right? That means A tends to alpha B. So for this E dash we need to find. So look at this. The follow of B, that means the follow of E dash should be the follow of A. So here as per this rule, the follow of E dash is follow of E. Okay. Then where the E dash is present? Here. Okay. So here it also, but if you are it doesn't follows any of the rule, because here A tends to alpha beta. We can't include this two element as a single thing. So we are eliminating this one. We are not considering this production for finding our follow. Okay. Then follow of T. So check where the T is present here. Here in this first production, that is A tends to alpha. That means, sorry, here the thing is, this is B, the beta, but B doesn't have any rule like that. So we are not including this one. While finding the follow, the production must be like this. Either A tends to alpha B beta, or the A tends to alpha B. So the follow you are going to find is this element, or it should be present at the between or at the end. Okay, not at the front. Okay. Then look at this production. Here the T is present, like A tends to alpha B beta. Okay. So as per the second rule, we need to we know that the follow of T is the first of E dash. So what are all the elements present in the first of E dash? Plus and epsilon. Okay. And we know that we should not include epsilon in the follow. So I am writing this plus. Then if you are applying that epsilon into this E dash, so it will become like this production, A tends to alpha beta. Then here if you are applying epsilon here, then it will be plus T. So the follow of T should be, T will be follow. What are all the follows we are having in the E dash? It will be there. So plus dollar. So the follow of E dash will be as per this rule. Follow of E dash will be the follow of T. Okay. Then follow of T dash. Check where the T is present in this production. So sorry, T dash is here in this rule. So it is like alpha A tends to alpha B, right? So in this case, and as per the second rule, we know that, sorry, as per the third rule, we know that, and the follow of T dash will be, what are all the follows we are having in our T. So plus dollar, then close bracket, then we are having T dash here in this production, but as I said, we cannot consider two element for in replacement with alpha, so we are not considered in this production. Then we need to find the follow of f. So here in this grammar, these two production having f in this left side. So here A tends to, it is not following any of the two rules, so we are not considering this one. So here this production gives A tends to alpha, B, beta. Okay. So it is present, f is presented in between two elements. So as per the second rule, the first of T dash will be the follow of f. So what are all the T dash having first? Star and epsilon. We should not include epsilon into your follow. So then if you are applying epsilon into it, it will become like a third production. Then we have to write what are all the follow we are having for T dash will be the thing. So plus dollar and close bracket. So likewise we need to find the follow. Okay, what are all the grammar you will be getting for your for solving your non-recursive predictive parsing? We need to check whether the grammar is having any left recursion. In order, if in case if it is having left recursion, then we need to eliminate that left recursion. Then we need to, the next step is to find the first of the given grammar. So for finding the first one, we need first we need to check the right hand side production, and if it is generating the first, what are the element generated first should be checked. If the generated element is a non-terminal, then we have to check the further production until we are finding any terminal. Then we have to find the follow. For finding the follow, this is the set of rule. The start symbol should contain dollar. Then the sample production like this, or the element which we are going to find the follow should present at the in between or at the end. Then these steps to be followed. Okay. Now after finding this, after finding the first and follow, we need to write the parsing table. So for drawing your parsing table, you have to write all your production element E, E dash, T, T dash and F. Okay. In your row, we have to write ID. What are all the terminals you are having? You have to write all the non-terminals here, and you have to write the terminals there. So ID plus star, open bracket, close bracket and dollar. Okay. So in our follow of the start symbol, it contains dollar, right? So we have to include that as a non-terminal here. So in this, let me write. So after finding the first and follow for the given grammar production, we need to draw the parsing table in order to solve any given input string, whether it is, we need to check whether it is accepting or not. So here I have written the first of all the grammar production and follow of all the grammar productions. So now we need to check the first of E, okay. What are all the elements present in first of E? Open bracket and ID. So in this two column we need to fill the production, okay. So here E tends to T E dash, that is the production for E, and for open bracket T. E tends to T E dash, okay. Then what are all the, as per the first of the given grammar, we need to write the parsing table. We need to fill the parsing table. So here look at the first of E dash, it contains plus and epsilon, right. So if the first of epsilon contains, first of any grammar contains epsilon, then we should not write that epsilon into your parsing table. Instead of that, if you are having epsilon, we need to check with the follow of that grammar, that production, okay. Here for this plus, so for E dash we are having two production, that is E dash tends to plus T E dash or epsilon, okay. So we need to write this production into this plus T E dash. Then for this epsilon, we need to check the follow of E dash. So the follow of E dash is dollar and close bracket. So in that column, we need to write this production. So dollar, in this dollar, E dash tends to epsilon, then in close bracket. So E dash tends to epsilon. So likewise, you have to fill. If you are having, we need to check the first for filling the parsing table. If you are having epsilon in your first of any production, any non-terminal, then we need to check with the follow, okay. Then now we are going to check the first of T. First of T is open bracket and ID. So T is having only one production, that is FT dash. So we have to write that in ID and open bracket, that is T tends to F T dash. So in also in the open bracket we need to write T tends to F T dash, okay. Then now we have to check with the first of T dash, it contains star and epsilon, okay. For star, here for T dash we are having two production, that is star FT dash as well as epsilon, okay. Now first we have to fill with the for the star, okay, that is T dash tends to star F T dash. Then as we know that if you are having epsilon in your first, we need to check with the follow. So follow of T dash is plus dollar and close bracket. In that columns we need to fill this production, that is T dash tends to epsilon. So plus T dash tends to epsilon in dollar, T dash tends to epsilon, and also in close bracket T dash tends to epsilon. Then next, first of F contains open bracket and ID. F contains two productions. So here open bracket and ID we have to write it separately. Open bracket, F tends to this one. Then for ID, F tends to ID. And the important thing is, if in this parsing, after filling this parsing table, we need to check whether each and every column should contain only one production. If it is having more than one production, it will not accept any string. It will, after, if you are going for the further stack implementation, it will not accept any string, okay. So we can stop the process here itself. If you are having multiple production, that means more than one production in any column of your parsing table, okay. So the parsing table should, it can be empty, but it should contain, if it is containing any production, that should be only one production, okay. So what we are writing, look, for F we are having even two production, but we have to write the concerned production for each and every column. That means for open bracket we have to write this one, and for ID column we have to write F tends to ID, okay. This is the parsing table. By using this parsing table, if you are given with any kind of input string, we need to check whether the given set of grammar accepting that input, okay. So we know that parsing is a process of checking the continuous stream of input string, whether it is accepting with your grammar, that is whether it accepts the formal grammar. Okay. Now I am considering one input string, and we will be checking that input string for this whether it is accepting the by using this non-recursive predictive parsing. So let us consider the input string id plus id star id. So we need to check whether the given set of grammar, this grammar accepts the string id plus id star id. Okay. For checking this, we need a stack, then our input, then our output. So the initially dollar symbol should be placed in the stack in order to start initializing any process into the stack. So then we have to write the start symbol of your production. Here E is the start symbol. So in this input column, we need to write our input string, whatever the string has been given, and we also close that with star dollar. Sorry, why we are using this dollar here? So whether at the end of the parsing, this both dollars should remain. So that that states that the given string is accepted by the stated grammar. Okay. Now here, in order to solve this string, we need to replace this production with your by using your parsing table. So here E tends to, in order to, for id in your parsing table, under id column E will be giving E tends to T E dash. Okay. Then we have to put this element. So we are now what we are doing, this we are replacing this non-terminal E with T E dash. So now we have to push this element into your, this production into your stack. So while you are pushing, the last element will be pushed first, right? So dollar E dash T. So and the input will remain same, no changes will be there. Okay. Then now we are checking with T. So in your parsing table, T and ED, what sorry, ID, under T and ID column, the element will be T tends to F T dash. Okay. What we are doing is, we have to check with the parsing table. In that parsing table, in the under the combination of T and ID, what is the production generated? That is T tends to F T dash. Okay. Now we are replacing this T with F T dash in your stack. So now we are pushing that element into your stack. So it will be pushed like E dash T dash then F. Okay. Since if you are putting the element into your stack, the last element will be pushed first, and then the first element will be pushed at the top. It will be at the top. Okay. Now still now no more changes in your input. Okay. Then now you have to check with this element and this one. Under in your parsing table, in the combination of F and ID, the production will be as F tends to ID. Okay. Now look at this. This output element also will be the input, first element of the input is ID. It matches with the output element. So what we have to do is, this element will be removed by replacing this. By replacing this F with in your stack, this ID will be removed. Okay. So the next production will be E dash T dash plus ID star ID dollar. Okay. Now we are going to check with this T dash with my plus. Okay. But in your parsing table, this T dash doesn't have any production under the column plus. So we can simply replace this T dash with epsilon. That means we are just removing that element because it doesn't matches with any production. So we can just remove that element from your stack. Okay. Then now E dash will be there plus ID star ID dollar. Okay. So if you are check with the this combination E dash and plus in your parsing table, it will give, it has a production like plus T E dash. Okay. Now look at this, this plus which matches with your output. So we can remove that from your input. So in order to replace this E dash, we will be pushing that element into your, that is E dash T. So here this plus will be removed. Okay. Then the remaining input will be ID star ID dollar. Okay. Now this T and ID should be checked. Okay. Then F T dash. Okay. Under the column of ID and T combination of your parsing table, it gives the production like T tends to F T dash. Okay. Then if you are pushing that element into your stack, in order to replace your T, it will become E dash, T dash and F. Input doesn't have any changes now. Then now, so here look at this, F and ID in the parsing table, it has the generation like production like F tends to ID. Okay. So this ID and this ID will be removed. E T dash star ID dollar. Okay. So for this T dash, under in parsing table for star we are having T dash star F T dash. Okay. So after replacing this element, E dash T dash F. Okay. Then the star will be removed, ID remains in this input. Then now you are going to check with this F and ID combination of your parsing table has the production F tends to ID. So also it gets removed, E dash T dash, F was replaced by ID, then now the input will become dollar. Okay. So but still we are having elements in our stack. So we are having a production like T dash tends to epsilon, then E dash dollar, E dash tends to epsilon, then dollar, then dollar. So here the given string is accepted. So in order to check whether it is accepted or not, it has to state like that. That means the stack should contain dollar, and all the elements in your input string should be removed. The dollar should be remained. So this is how we need to check whether the given input string is accepted by the given grammar or not. Okay, this is all about non-recursive predictive parsing. So we for the given grammar, we need to eliminate the left recursion. In that case, if it is having any left recursive production, then we need to find the first of that left recursive eliminated grammar, then follow, then using that first and follow, we need to draw a parsing table. After, but with the help of that parsing table, we need to check whether given grammar accepts any input string or not, whether if any element is still remaining in your stack or in your input, then we can conclude that string was not accepted by the given grammar. And also one hint is, in your parsing table, if you are having one or more production in any column of your parsing table, then you can conclude that it will not it will not accept any of the string given. Okay, thank you.